Today we're talking about algebraic proofs, and we want to use algebra to write two-column proofs and use properties of equality to write geometric proofs. So the definition of a proof is a logical argument in which each statement you make is supported with a reason that is accepted as true. So the reason that we can say something, you can't just go around saying things. You have to have something to back it up as proof. And properties, theorems, postulates, and definitions are all examples of reasons. So there are a few different kinds of proofs, and the one that we're really going to focus on is two-column proof. You could also have a paragraph proof. You still have a given and a prove, but the manner in which you go about proving it is basically you're just continuously writing in your statements and reasons are listed inside the proof. Another way that you could do it is you could do a flow chart where you have your given. In this case, we have two givens, and you just kind of follow a flow chart, kind of similar to computer programming, and you still end up where you want to see what you want to show at the end. But the one we're really going to look at is we have a two-column proof. And here we go. So given x is the midpoint of line segment SY. So I'm going to go ahead and draw that to begin with. And I want to just make sure that it makes it on the drawing here. So it doesn't have to be exact, but it helps to draw and kind of measure what is happening there. So it's in the midpoint. So I measured 1/2 inch and put the dot for x. So that is right in the middle. And then we have SY. And then it has Z is the midpoint of YF. Well, we already have one Y drawn here. And what we're trying to prove, and then we know that XY is going to be congruent to YZ or equal to YZ. So again, I already kind of measured this and I want to make sure that it looks the same as it did before. So I'm going to go ahead and draw that. So that's 1 inch, and then I'm going to mark it as 1/2 inch in the middle. And then my drawing should look about drawn correctly. So Z is the midpoint and midpoint of YF. And then we have XY is equal to YZ. And the way that we show that is we make those congruent marks on here. So it says XY, so there's XY. If I put 2 here, then we want to show YZ. So we're going to get our sketch going. And when we're looking at the parts of a two-column proof, there are 5 parts that we want to pay attention to. And the first one that we want to pay attention to is the given. So we need to understand what's given there. The next thing we want to pay attention to is the proof. What are we trying to prove? So we have this given information, but what are we trying to prove? And what we're trying to prove is the line segment ZF. So ZF is congruent to SX. So that's what we're trying to prove there, and hopefully we'll be able to do it. The next thing that we want to look at is the diagram. So that's the third part. We got to make sure we have a good diagram that can help us solve what we're trying to find, or solve what we're trying to prove. And the next part after that, we have our statements and our reasons that we can make those statements. Can't just go around saying things. We gotta have proof or reasons why we can say that. So X is the midpoint of line segment SY. Line segment SY is the point of line segment FYF, and XY is equal to YZ. The reason, given. So when we're doing this on our test, if we have a given and we write that information in the first box and then write given, that will be worth 2 points right there. So because we were told that X is the midpoint and because we were told that Z is the midpoint, we can say that Sx is congruent to xy. So Sx is congruent to xy. And we already have 2 marks there. So because we already have 2 marks there, we're going to put 2 marks there. And the reason that we can say that is because there's the midpoint, and the definition of midpoint is it creates 2 equal sides. The other thing that we have here is YZ is congruent to ZF, so we can continue making those marks, and that's the same because it already told us the midpoint. So from there we can say XY is congruent to YZ. So we can say XY is congruent to YZ definition of congruence. Because previously we didn't say that it was congruent. Here we said it was equal to. So if something is equal, then it is congruent also. So that's why it was definition of congruence. That's why we had to say that there. Next, we can move on to Sx. Right here, Sx is congruent to YZ. And that is transitive property of congruence. So we've already said that, let's see here, with this one we said Sx. So we already said that Sx was congruent to xy. And we already said that YZ, oh, that's the wrong color I grabbed there. We already said that YZ is also congruent to xy. And this is a tricky one, the transitive property. So because xs is congruent to xy and yz is also congruent to xy, that means they have to be congruent to each other by the transitive property. Next we have Sx is congruent to Zf, also by the transitive property. And so we have Sx listed a few times. Here we said Sx is congruent to Yz. And here we have Yz, so it's kind of the same thing. So again, we have Sx, which we talked about earlier, and that is congruent to Zf. And we haven't done Zf yet, so I'll put that with a blue. And we can see, where do we see Zf? Well, here's Zf, okay? And that's Yz. We've already talked about Yz. So because Sx is congruent to Yz, and Zf is also congruent to Yz, that means that those two have to be congruent to each other. And then the last one, the symmetric property, all we did was we just switched the order here. So we moved Sx to the second segment, and we moved line segment Zf to the first segment, and that's the symmetric property where we just switch them. And so that is a general outline of what a proof might look